Hello class, welcome to our lecture number 2 for our subject, Statics of Rigid Bodies. Let me share my screen and present to you our lecture. So lecture 2 will talk about resultant of original forces. Okay, let us define first. We have mentioned before that forces are characterized by the magnitude of its magnitude, its point of application, and its direction. Okay, but essentially resultant are series of forces, two or more, that can be combined into one singular force, or the single equivalent force having the same effect as the original forces acting on the particle. In this case, we have force vectors P and Q acting on particle A or body A. It can be represented to one resultant equivalent force. Okay? The resultant can be obtained through these two procedures or two methods, the parallelogram law of vector addition and the triangle rule. So let's proceed. What is the difference? The difference between the two? The parallelogram law essentially, we get the diagonal of the parallelogram that was formed from the forces. Okay, so in this case, R and P, we made the parallelogram and connect the diagonal. We get the resultant R. However, for the triangle rule or the triangle law, we connect it head to tail. So in this case, P and Q, move Q to the head of P, and then connect A to Q. That will be our resultant. So the vectors are defined as mathematical expression possessing magnitude and direction. Unlike your scalar quantities, only magnitude, which add according to the parallelogram law. So we are only following the rule for addition of vectors. Okay. So it follows also the law of cosines. R squared is equal to P squared. The magnitude of R is the square root of P squared plus Q squared minus 2PQ, cosine of the included angle B. Okay. And the law of sines, so we already know this from our trigonometry. That is why class that statics requires algebra, okay, as a prerequisite, and trigonometry. Again, addition of vectors is commutative, so these are just properties. So we can easily revert. Okay. P plus Q is also Q plus P. The sum of vectors, if the vectors are coplanar, the resultant may be obtained by using the polygon rule for addition of vectors. If there are many vectors, not just two, okay, so we can easily do that. How about another property, that vector addition is associative, meaning we can group, okay, or you have a specific vectors, many vectors, you can what you call this, change, okay, change the magpalit-palit, interchange, okay, like in the vector addition. In this case, S was first before the Q, but we'll give you the same equivalent R. The product of a scalar and a vector, so 2P, is the same magnitude as P with magnitude 2P. Okay. In this case, we have P and 1.5P and then negative 2P. Again, class, negative doesn't mean you have a decreased value. The negative indicates direction. So in this case, the negative 2p points downward or to the left. That's why it is negative. Resultant of several concurrent forces. So if you have series of forces, the set of forces which all pass through the same point. In this case, point A. Okay? For the diagram A. But for B, we don't have a concurrent point. Okay? Vector force components, two or more force vectors which together have the same effect as a single force. So for example, this is a book example class, so you can check it also in our books and manuals. So we are tasked to find the resultant of this free body diagram from particle A. This is a screw which is applied two forces. So using the triangle law or trigonometric solution, we have this diagram, so we can easily use the law of cosines. Okay. So as we can see here, so let me show my laser pointer. So in this case, we will the force vector Q is moved to the head of P, this one, and then connect the two. So we know both their magnitudes and their direction. That's why the included angle is 155 degrees. So simply substituting from the law of cosines, P squared plus Q squared will give minus 2PQ cosine of the included angle B will give us 97.73 newtons. The law of sines, sine 55 opposite it, sine 155 over R is equivalent to this included angle or this angle over 60 Newton, or in this case, that will be 97.73 degrees. So that is sine A over Q is equal to sine B. B is your 155 degrees over R, the resultant. Okay, so we're solving for this one, okay, the alpha. So 15.04, the angle A, this one, not the hula, because we are finding alpha, is that will be 20 plus A, 35.04 degrees. Chicken fit, so easy, okay? So that will be it for our lecture 2. For additional examples and problem sets, wait upon our synchronous session. Thank you all, and God bless you all.